Hello students, today I am going to start the new chapter circle. You know that what is called circle and the term related to the circle, that is what is the interior of the circle, what is exterior of the circle, what is the definition of chord, diameter, segment, arc, minor arc, major arc. I hope you all know that. And what is the circumference of the circle, semicircle? All you know that in your previous class you already learned about this. Now, first I discuss about what is the sector of the circle. Suppose if we draw two radius and the arc of the circle, make a closed figure. This closed region is the sector of the circle, and this is also the sector of the circle. And if we say that it is the minor and major, you all know that this is called minor sector, minor, and this is major, right? Major sector. Now, segment of a circle, you know that if a chord of a circle divides its circle region into two parts. Suppose I draw another circle to show you. You know that the biggest chord of a circle is the diameter. If I draw another chord which divide the circle in two parts, and this part is the minor segment of the circle, and this is the major segment of the circle. Now, next is what is angle subtended by an arc. The angle subtended by the two bounding radius or radii of an arc of a circle that at the center of the circle is called angle subtended by the arc. That means both are the radius and this arc make a region, right? And this angle made by the two radii is called the angle subtended by the region. Subtended by an arc. You can draw another. Suppose if we draw this side, this angle is also known as the angle subtended by the arc. Suppose if we draw this and this angle PRQ, suppose name is PRQ and this is O. This angle R is also called the angle subtended by the minor arc. This is called the minor arc because this is the minor arc. For this arc, this region is made, and this is the major arc. Okay, now next is angle subtended by a chord. What is that? Draw over here. Say PQ is a chord. This is P and Q is a chord. Okay. Now this is the center O. Okay. Let R and A's be the point on the R is the point on the minor sector and A's be the point on the major sector. Okay. Now you have to join OP and OQ. Joint OP and OQ. Okay. Here this angle is made. Okay. So angle POQ is called angle subtended by the chord PQ at the center of O. This angle made by the chord and this angle made by the radii. So angle subtended by the R and angle subtended by a chord. Now next is join PR and QR, PS and QS. PR, QR and PS and QS, right? Okay, so PRQ and PSQ are the angles subtended by the chord. For this chord is what? PQ. And for this also the angle made by the chord. Okay, PQ. So for R it is for the minor arc, and this for S it is for the major arc. What is concentric circle? If two or more circles are drawn with the same center but different radius. Same center but different radius. These all are known as concentric circle. Okay. Now, some properties of circles. We will discuss some properties, chord properties of the circle. First theorem is the straight line drawn from the center of a circle to bisects a chord which is not a diameter is perpendicular to the chord. What is the meaning of this theorem? First, I have to draw the circle. Okay, this is the center. We always draw the circle with the help of a compass. Okay, now this is the center. It is said that the straight line drawn from the center, if we draw a line center of a circle to bisect a chord, suppose here this is a chord, name is A and M. You have to prove that this straight line divide the chord into two equal parts, bisect the chord, and O, suppose name of this OM and AB is the chord. Okay, OM perpendicular on AB. So for this we have to join OA and OB. Now see, OM and OB are the radius of the circle, because radius definition is what? Radius means the distance from the center to a point of a circle, and it is always equal in every point of the circle from the center. So here OA is equals to OB. Okay. It said that M is the midpoint. The straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. So OM, M is the center. So AM is equals to MB, because M is the midpoint of AB. Both are ready. Okay. Now third property is what? If we take both this triangle OAM and the triangle OB and M, what is the common factor between these two triangles? OA equals to OB, AM equals to MB, because this and this M is the midpoint of AB, and OM is equals to OM because this is common in both the triangles. So we can say that both the triangle are congruent. If it is congruent, we can easily say that OAMO or OMA, angle AMO is equals to angle BMO. Okay. And angle AMO plus angle BMO equals to 180 degree, because AB is the straight line, right? Straight line. So we can say that in place of AMO, if we write BMO, so 2AMO equals to 180 degree, or you can say that AMO equals to 90 degree. So AMO equals to 90 degree and BMO is also 90 degrees, and we can say that OM is perpendicular on AB, right? Okay. Now, I am discuss about the converse theorem of this. Converse theorem said that, what is the converse theorem? First I have to rub this. Just opposite. What is that? The perpendicular drawn to the chord from the center of the circle bisect the chord. Bisect the chord means here we have to prove that AM equals to MB. So, first I have to write the theorem. The perpendicular to a chord from the center of the circle bisect the chord. So that means to prove what? AM equals to MB. So take this triangle. OA equals to OB because both are radius. Now here it is already said that the ON is the perpendicular on AB. That means OMA and OMB both are 90 degree. So here you can write, it is already said that it is a perpendicular, so we can write angle AMO equals to angle OMB equals to 90 degree because OM is perpendicular on AB, right? Now OM equals to OM, both are common in both this triangle, so we can say that both the triangle are congruence. So if it is congruence, we can say that AM equals to MB. This is proved. Now next class we will discuss the next theorem, that is equal chord of a circle are equidistant from the center and its converse theorem. Thank you.